Hello everyone. We are now moving on to Unit 4, Chapter 6.1, Graphs of Relations. Match each graph with a situation from the list. Explain your choice. Suggest titles for each axis to show the quantities being compared. We were given graph A through D, and let's quickly take a look at what is going on. So for graph A, the value is increasing, and then after a certain point, it decreases. For graph B, the value increases at a constant rate, and then it's not changing. Graph C, the value starts up here, and then it decreases quite steeply. Lastly, for graph D, we start at 0, and it's increasing at a constant rate. Now let's take a look at these given situations. Part A, the temperature of a cup of hot chocolate over time. So we're given the temperature of a cup and time. So this situation would involve temperature versus time. Temperature should start quite high and it's decreasing over time. Temperature is decreasing over time. So the graph should be decreasing. Time always comes on the x-axis because it's independent variable, and I'll discuss this a little more later on. But for now, assume that time is always on the horizontal axis, and temperature will be on the y-axis. And like I said before, temperature is decreasing over time, so the graph should be decreasing over time as well. So let's say we start at a higher value of temperature because it's quite hot, and it's decreasing over time. And anything that resembles this particular situation would be graph C. Let's take a look at part B. A car accelerating to a constant speed. So when something is accelerating, it means there's a change of speed over time. And the speed is change of distance over time. So we know that the situation involves speed and time. So we can say that maybe the title of this graph could be speed versus time. Let's try graphing. So because we know the title of this situation, we can put the time on the x-axis and speed on the y-axis. I also know that a car is accelerating, which means is increasing. So speed is increasing. And then secondly, it says to a constant speed. So, and then speed is not changing. So we can say that the car starts at speed of 0 because it's probably at a stop. And then it's increasing. Speed is increasing. And then after a certain point, speed does not change. And now you kind of see that this resembles graph B. From the initial position, the car has increased its speed until a certain point. So speed goes up until a certain point, and then after a while, the speed of the car does not change. So it maintains a constant speed as time passes by. Moving on to part C. the distance a person walks during a hike. So we were given the distance a person walks during a hike. So we're dealing with distance, and then it says during a hike. So that's during a certain amount of time. So again, this graph would be in terms of time. So let's set up our graph. So this is going to be in terms of time, and then we have distance on the top. This person starts at 0 because before, like in the beginning of the hike, you don't really walk, so the distance is 0. And then the distance will increase over time. Would it ever decrease during this time or during the hike? Can you undo your walk or go backwards, go negative walks? No, you probably can't. Realistically, that's impossible, and so this graph will continue to increase as long as this person continues to walk. All right, so we can see that there's graph D that looks quite similar to our graph here. So we have graph D as an answer. All right, let's take a look at the last one. Part D, the height of a soccer ball kicked across the field. All right, so we can kind of see that keyword, height of a soccer ball kicked across the field. So here's the thing. If you take a look at the previous examples, I kind of highlighted two key terms. For part A, I highlighted the temperature over time. Second one, I did accelerating and the speed. Third, I did distance during a hike, as in time. But for part D, that looks a bit off. Right? So what they're trying to say is that they want the graph to be showing us the height versus something. What doesn't change or what moves on when the height of a soccer ball changes? So I know, for example, let's say this is height. I know that the soccer ball starts at 0 because it's on the ground, and I know it's going up to a certain point. And then you know that that ball at some point will start to come down. So after a certain point, I know it's going to come down to the ground. So what would the x-axis be? We start here and end here. What passes as the height changes? Ball shoots up. So the ball shoots up, and then that peak, the highest point is where the ball could ever go up to, and then the ball will start to fall. And we know that this situation must be in terms of time. So we have height versus time graph. So graph A would be a graph that represents the situation. Moving on to next page. Interpret a graph. Wakeboarding has grown to be a popular water sport. The graph shows the distance that a wakeboarder is from her starting point on Last Mountain Lake in Saskatchewan. Describe what the boarder is doing. So they give us a graph, which is a distance from start over time graph. Let me highlight certain areas. So the distance from the start had a slow increasing here movement, and then it goes up constantly. After a certain point, from B to C, this distance doesn't change. And from C to D, distance increases at a faster rate, so steeper. The graph looks steeper than A to B. And then we can see that D to E we drop down in distance from the start. And then E to F, the distance didn't change, it's constant. So from F to G, the distance decreases and it looks like the distance went to 0. So distance from the start went to 0. So which means that this person has come back to the starting point. Let's take a look at A to B. From the graph, we could assume that the distance is increasing, and then it kind of starts slowly, like it didn't have as steep of a change in the beginning. So we know that this wakeboarder has started slowly, but speeds up quickly after. So also, because the distance from the start is increasing, we can say that the wakeboarder is moving away from the starting point at a constant speed. Moving away from the starting point. Now let's take a look at part B to C. So B to C right here. So we can see that the distance from the start, that distance is not changing. It's at this value and it's constant. It's not moving. So we can say that the distance is not changing, which means this wakeboarder is probably just not moving at all. So either taking a break, or we can also assume that she's moving in a path that keeps her at a constant distance away from the starting point. So let's say this is a starting point. She moved north like 10 meters. So that would be, so this indicates the distance from the start is 10 meters. But if she were to move from this point to this point in a circular motion, then this is technically still 10-meter distance, right? Because from here to here is 10 meters. So our distance from the start doesn't change because this is where we started. Although I went from here to here and here to here, the graph doesn't show. So most likely she's just taking a break. So we'll say the distance is constant because she's taking a break. All right, so let's take a look at C to D. C to D is that little section there. And we can kind of assume that the distance has increased quite quickly compared to A to B. So the distance is increasing at a faster rate. And also she's moving away from the starting point because it's increasing. Now let's take a look at next case, D to E. So D to E is here. Right, so we know that the distance is decreasing. And she is moving toward the starting point because the distance is decreasing. So moving toward the starting point. And we'll just leave it at that. And let's take a look at E to F. E to F, again, that looks like the distance is not changing. So we can assume that she's taking a break. Taking a break. And lastly, F to G is the last bit here. So it looks like the distance is decreasing to 0, which means the rider has returned back to the starting point. So that's it for 6.1.